Okay, ladies and gentlemen, this is like fourth time trying to get this work. First time video didn't work, then the audio was garbled, so I just had problems. So let's see if I can get this working this time. Okay, Ice Island, Chapter 15 with Group 7, Tyler Watson and Sterling Wright. Okay, so this chapter has a lot of charts and statistical analysis, and I hope I can make it a little clearer. I hope I help make things easier to be understood. So we want to do outlier detection. So, for example, Netflix, they had a whole bunch of nodes, and they compare it against each other to see if there's any one of them that is not behaving like it is expected to. And if it's running slow, way slower than it should, delivering video slower than it should, they say that server's bad and they kill it, sometimes automatically. And so they can figure out if they need to replace something, if they need to fix it, or if they just need to toss the node and just replace it. Airlines use similar tests, and basically we're just trying to find what parts are running differently. Everything should be running smoothly and predictably because they're all running on the same code because we're using a single trunk, hopefully. We want to use statistics and standard statistical models to detect problems. So right here we've got an image of a bell curve. This is also called a normal distribution because it's what's seen in nature often. For example, the height of males is going to form one of these bell curves, with 0 being the average height of males, and 68 or thereabouts % of people being within one deviation. We want to find, and so variance is how closely are the numbers to the statistical mean. Basically, is it a tall mountain like this, or is it a little flatter? Sometimes people are a little bit more flatter. And deviation is how far away is a point from the mean. Short X bar is another way of analyzing the predicted results. X bar means the average. It's just the X bar is a technical term meaning average. So we've got that green line in the middle, the X bar, and then we have the line at the top, which is UCL. The line at the bottom is LCL. UCL is upper control limit, LCL is lower control limit. And this is a way of charting the results to make sure everything stays within that. Now, if the numbers are getting constantly on one side or the other of the green line, it means that the average has changed, and you might want to find out why. That is, maybe your programs are just running a little slower, or needing more RAM, or maybe it's paging too much, and maybe you need to just adjust the chart. Maybe you need to adjust your programs. But if it goes outside the red lines, you probably want to send a red flag and let people find out, why is it outside the lines? Are we going to need to do something about it before it becomes a problem and an outage? We want to create instruments and alerts to understand on undesired outcomes. So we need to, ultimately, that our ideal is to warn us of impending outage before impending outages happen. Applications are load times taking too long. Maybe on the OS, we want to check how much RAM is being used, how much disk space we're having. Are we running out of disk space? Database and transactions taking too long. Is that because it's a backlog? Do we need to put more indices on the tables? Do we need to merge or split tables? And network layers, we want to know that the load balance is working, that things are the servers on the other side of the network layers are not being improperly utilized. And maybe you want to put alerts on other undesired outcomes. These are just examples. So Gaussian or normal, as we saw in this bell curve is a normal, sometimes referred to as a Gaussian, is useful for a lot of things, but not everything. The bell curve, usually if you're within 1 delta, you're at 68% of the population data points within 1 delta. If you're within 3 delta, you're at 99.7%. Now, if you're outside 3 delta, in theory, only 0.3% of data points would alert you. But if you apply this to something where the mean is 0, you're probably going to 0 if there's no negatives. It means that you're probably going to be sending up a lot more alerts than you expect. If most of it's 0, but occasionally you get 5, you might be flagging it as being a potential error when you get 5. Maybe this is downloads at any given time. Maybe I've got a server that's downloading operating systems. Doesn't get hit often, but when it does, maybe it gets hit 4 or 5 times and it's not a problem because the server's made to handle 4 or 5 downloads at a time. And so, but that 5 might be outside of the delta 3, and that could be a problem. That could let them make it could be a problem because you'd be getting false alarms all the time about stuff that's not a problem. Netflix had similar problems that they couldn't follow normal prediction models, and so they used fast Fourier transformation and linear regression to great benefit. They found there was a bit of a up and down throughout the day, and that there was a prediction of busier on Monday than they were on Friday. So they were able to make a prediction model about how many at any given hour they would need. I believe I might be talking about Amazon and their servers that they had to upload. So we want to find out what our data looks like and find models that help us represent the data so that we know when things aren't behaving the way they ought to. Right here on the chart on the right is a Kolmogorov-Smirnov test. It shows you the difference between the predicted and the actual, and if that difference gets too big, you might want to find out why. Maybe you predict at this point in the day you should have X hundreds of thousands of logins of users currently logged in, but you've only got 15 logged in. Well, that's a problem because it means that people probably aren't able to log in. Maybe you expect 200,000 logins and you got 1 million logins. That's a different problem because maybe you need to find out if you're part of a distributed denial service attack or if you've got a burst of sudden popularity you need to adjust so that the people who are logging in get the expected results. So we want to see, so that's why we might want to have a chart that shows the difference between expected and reality. And moving average can help smooth out data so that short-term spikes don't cause don't cause alarms as if they were fatal errors. As I mentioned, compare your data from last week as well as 24 hours ago. You find that more informative. And here's the link. I hope I was clear. I hope I helped you understand the need for data as an informative model. You all have a good day.